Assalamu alaikum, Shabab. Sorry, in our class this morning, I actually wanted to show you a demo of a program that solves CSP problems, and you may need that example actually to be able to solve question 6 in the assignment. Question 6 says, based on your updated domains in 4B, write a Python program using the Python-Constraint library similar to the example given to you to solve this problem. So actually this is the example I wanted to show you in the class, but somehow it skipped my mind. So I'll try to record the demonstration of this example so that you can have a look at it before you attempt to solve the problem, especially this question 6. If you go to Blackboard under examples and demos, you will see here CSP example, which is actually trying to solve the Australian map coloring problem. So assume you have already installed Python, as I encourage you to do for last class. You need to unzip this example and then open it from whatever editor you are using for your Python application. I have already opened the content of that zip file here. It contains actually two programs, australia.py and australia2.py. Australia.py is actually trying to directly, without using any library, implement the backtrack algorithm to solve the Australian coloring problem. So if I may just go through that first of all, although it's not the one I want you to use for the assignment. I want you to use australia2.py, which actually uses the library. But you can actually solve it even without the library. So here, as you can see, I define my variables. The variables are the 6 Australian regions. 1, 2, 3, 4, 5, 6, 7, actually 7 regions. So I define them here as a list, and then the constraints also I define it as a list. The only thing here is each element in the list is a tuple. So WA NT as a tuple means WA should not be equal to NT. Western Australia should not be equal to Northern Territory because they are bordering each other, and so on. These are the binary constraints in that program. So I define in that example. So I define my variables, I define my constraints, and then this is the backtracking algorithm, very similar to what we have in the slide. It is implemented as a recursive algorithm. You can see it is calling itself here. So actually when you call it the first time, you need to give it an empty assignment. Assignment is a set, as you're gonna see. Let me show you where we are calling the backtracking method. This is where we are calling it in the main. So we create an empty dictionary and pass it to the method. It will go and do all the assignment and return to us a solution, and that is what we are printing out. Okay, so this backtrack algorithm, it means it will come with an empty dictionary. Of course, assignment, you can think of it as a dictionary, each variable against a value, variable, value, and so on. So that's why we are using dictionary. So as we saw in the slides, the first thing is to check, have we completed all the assignments? So we will have completed the assignments if the length of our assignment dictionary here is the same as the number of variables. So each variable will have been assigned a value. If that is the case, just return the assignment. But otherwise, we're gonna select unassigned variable. Okay, so there's a method here that is doing that. It is basically going through all the variables and see which one is not in the assignment. Okay, the first one that is not in the assignment, return it. So we're not applying any of the heuristics that we learned today. Just return the first variable as in the list of variables without any consideration to which one is more important than the other. Okay, say for each variable in the list of variables, if variable is not in assignment, that's why we're receiving the list of current assignments as argument. If the variable is not in the list of already assigned variables, return it. So this is very easy, just bring the next unassigned variable. Okay, so that is what we have here. We call it var. The next thing is to assign a value to it. So again, we are not considering any heuristic in assigning the values. We're just going to take them in order: red, green, blue. So we are saying for value in these three possible values, make a copy of the assignment. So we have a new assignment here, which is a copy of the current set of assignments, and then add to that copy a new assignment. And to add a new assignment, all we have to say is new assignment at var equal to value. Okay, so this will basically assign a new assignment to the list of assignments. This is how you assign a value to dictionary variable. Now, having assigned this new variable, a value to this new variable, we need to check, is this assignment consistent? So again, there is a method here that is checking for consistency. We give it the new assignment, and it's going to try and return a result, which is Boolean. So that's why we're calling it Boolean if statement. So this is basically what this will do. So we check if the consistency is there. We do a recursive call with this new assignment. So you see the assignment list keep growing with each call. So this is how you may implement the backtracking algorithm manually without any library. If you run this example, you'll see that it will tell you this is a possible solution. So you can assign West Australia to be red, Northern Australia to be green, and so on and so forth. Okay, so this is a simple implementation directly where we code the program ourselves. However, this is not the example I want you to use in the assignment, because there is actually a library, a Python library that already implemented CSPs. Okay, if you go back to Blackboard and you go under resources and useful links, this is a link to the Python-Constraint library. If you click on it, it will automatically take you to the place you can download the library. And actually, the way to install it in your system is just to say pip install Python-Constraint. So of course, when you install Python, by default this library will not be there, but you can use this command to install it in your system. So at this point you have the library. It is called Python-Constraint as a library. And in fact, on Blackboard there is also another file here. I think it's a PowerPoint, which is a tutorial on how to use this Python library. So you can have a look at that one as well. But actually, from the example I'm going to show you now, you can easily do it even without looking at this tutorial. So let's go back to the example. This is the second way of solving the Australian problem, but this time using the Python-Constraint library. So as you can see here, we have to import the library after you have installed it into your system. Now in the program, you have to say from constraint import everything, because actually there are a number of files in that library. So this will do the import, and then once you import, there are basically 4 steps you need to follow. Number 1, create a problem. So one of the class in this library, one of the classes in this library is problem. So you create a problem simply by saying problem equal to problem. You know, in Python you don't have to say new to create an object. You just say problem equal to new problem. This will create an instance of the problem class, which we call problem. So this is step 1. Step number 2 is, once we create a problem, we're gonna add the variables. We add the domains. Actually, when adding the variables, we add the domain together, each variable with its domain. In fact, if all variables have the same domains, then you can do that in one call by using the method add variables. So this is what I'm doing here. Problem dot, so this problem is an object. One of its method is add variables. Notice that this is with S. So this we will use if all our variables have the same domains, or if some of the variables have the same domains, then you can add all of them together by calling this method. And as you can see, there are 2 arguments in the method. One is the list of variables, and the second is the list of domain. So we are saying each of these variables have the same domain. Okay, now in case some of your variables have different domain, then there is another method which I have commented here. Notice here it was without the S. Problem.add variable. So here you will give just the name of the variable, not a list. So this is one variable, comma, the domain for that variable as a list. Yeah, so we can do this one by one for each variable that has a different domain. This is how to add it to the problem. Okay, so that is step 2. We have added our variables and their domains. The next is to add the list of constraints. Okay, so here I have defined the constraint very similar to the way I did it in the other program. Constraint is just a list of the constraint that we have for this Australian problem, where the constraint here means this should not be equal to this, this should not be equal to this, and so on. So this just defines the constraint. They have not yet been added to the problem. How do we add the constraint to the problem? Very easy. Again, problem object has a method add constraint. Okay, so I can add all of this to the problem in a loop because they are all similar. Okay, they are all just a pair. In your example, there may be slightly different things, so you may have to use different ways of adding some of them, but it's very easy. So here I'm saying for each pair x, y in the list of constraints, so it's going to go through this pair one by one. Okay, each time I say problem.add constraint, and I define my constraint. The constraint is normally defined as a lambda expression. So the expression here is lambda of x comma y. So these are the two variables involved, and the constraint is that x should not be equal to y. So lambda x comma y colon x should not be equal to y, where x, y are in the form of a tuple. Okay, so this is the idea. So this will take this first and add it as a constraint that wa should not be equal to nt. Then it will take this again and add it. So in a loop we will have added all the constraints, and that is basically all we need to do. Create the problem, add the variables, add the constraints. The final thing is just to print the solution. Now here I want to print not just one solution, I want to print all possible solutions. So that problem object actually has a method getSolutions. So it will return to you all the possible solutions. And here I am printing them in a loop. Say for solution in this set of solutions, print the solution. Okay, that's all. Now if we run this, you will see that it will actually find all the possible solutions. In this case there are a number of solutions. Let's see if we can count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Actually more than 13. Yeah, so these are all the possible assignments that we can do for the Australian problems. Many of them are similar actually. It's just that what color do we start with for the Southern Australia? You see, in all of this, South Australia is blue. And then what if you start with green? What do you have? And so on. So these are all the possible combination of the solutions. And this is exactly what I want you to do in question 6 of the assignment. Okay, you already identified your variables, you have identified your domains, you have actually pruned the domains in some of the questions already in the assignments. So now on the pruned version of the domains which you have from 4b, say based on your outdated domains in 4b, write a Python program using this library to find the possible solutions. Okay, so don't add the original domains. Okay, use the ones that we already pruned from 4b. Okay, and then the question here says you need to attach the source code of your program as well as a screenshot of the output. So I need to see both. For you to get the full mark, I need to see your code. I also need to see your output. So just take a screenshot of your output and put it in your document. And also if you want the code, you can put it as a Python file, as a separate file, or you can just put it also as part of your document that you are going to submit for the rest of the assignment. It doesn't matter. Okay, so these are the 2 points I wanted to explain this morning, but somehow it skipped my mind, and I hope this will help you in your assignment. Thank you very much. Assalamu alaikum.